For centuries, humanity has gazed at the stars, yearning to unravel the mysteries of the cosmos. Among these celestial wonders, Mars, the red planet, has held a special place in our collective imagination. With its rusty hues and enigmatic features, Mars has beckoned us to explore its secrets and contemplate the possibility of life beyond Earth. Today, as we stand on the cusp of a new era in space exploration, the question arises: what if humans could live on Mars? The allure of Mars is undeniable. It is the most Earth-like planet in our solar system, with a day-night cycle similar to our own and the potential for water ice beneath its surface. The discovery of ancient riverbeds and other geological formations suggests that Mars may have once harbored life, further fueling our fascination with this enigmatic world. As our own planet faces growing environmental challenges, the prospect of establishing a human presence on Mars offers a tantalizing glimpse into a future where humanity could become a multi-planetary species. The journey to Mars will be fraught with challenges, but the rewards are immeasurable. Imagine a world where humans could walk on another planet, where we could build cities beneath a crimson sky and explore vast, uncharted territories. The knowledge and experience gained from such an endeavor would be invaluable, pushing the boundaries of science, technology, and our understanding of the universe. Moreover, the establishment of a self-sustaining colony on Mars would serve as a safeguard for humanity, ensuring our survival in the event of a catastrophic event on Earth. As we embark on this audacious journey, we must proceed with caution and responsibility. The ethical implications of colonizing another planet are profound, and we must ensure that our presence on Mars does not harm any potential life forms that may exist there. Furthermore, we must strive to create a just and equitable society on Mars, one that reflects the best of humanity and avoids the mistakes of our past. The challenges are great, but the potential rewards are even greater. Let us dare to dream of a future where humanity calls Mars home, a future where the stars themselves are no longer the limit. Mars, named after the Roman god of war, has captivated our imagination for millennia. Its distinctive reddish hue, visible even to the naked eye, has earned it the moniker Red Planet. This coloration arises from the presence of iron oxide, or rust, on its surface, a testament to the planet's ancient and dynamic geological history. But Mars is more than just a rusty sphere in the night sky. It is a world of breathtaking beauty and scientific wonder, offering tantalizing clues about the past and future of our solar system. One of the most striking features of Mars is its diverse and dramatic landscape. From the towering peak of Olympus Mons, the largest volcano in the solar system, to the sprawling canyons of Valles Marineris, a chasm so grand it dwarfs the Grand Canyon on Earth. Mars is a testament to the power of geological forces. These features, shaped by billions of years of volcanic activity, tectonic shifts, and meteorite impacts, provide scientists with a unique window into the evolution of rocky planets, including our own. Beyond its geological wonders, Mars also exhibits evidence of a once active water cycle. Ancient riverbeds, dried-up lake beds, and polar ice caps all point to a time when liquid water flowed freely on the Martian surface. This discovery has profound implications for the search for extraterrestrial life, as water is considered an essential ingredient for life as we know it. While the surface of Mars is now a cold and arid desert, the possibility of finding evidence of past or even present-day life in the Martian subsurface remains a tantalizing prospect. The thin Martian atmosphere, composed primarily of carbon dioxide, presents both challenges and opportunities for human exploration. While it offers little protection from harmful solar and cosmic radiation, it does allow for the possibility of generating breathable oxygen through processes like electrolysis. Furthermore, the Martian atmosphere is capable of supporting weather patterns, including dust storms that can engulf the entire planet. These storms, while potentially hazardous, also play a crucial role in shaping the Martian landscape and redistributing resources across the planet. While the allure of Mars is undeniable, transforming this alien world into a habitable home for humans will be a Herculean task. The red planet presents a myriad of challenges that must be overcome before we can even contemplate establishing a permanent human presence. From the harsh Martian environment to the psychological toll of long-duration spaceflight, the journey to Mars will test the limits of human ingenuity, resilience, and our ability to cooperate on an unprecedented scale. One of the most pressing challenges is the unforgiving Martian environment itself. With an average temperature of minus 63 degrees Celsius, Mars is far colder than even the most frigid regions on Earth. Its thin atmosphere offers little protection from the sun's harmful radiation, and the lack of a global magnetic field exposes the surface to dangerous levels of cosmic rays. These harsh conditions pose significant risks to human health and necessitate the development of robust life support systems and radiation shielding technologies. The journey to Mars, which could take anywhere from 6 to 9 months using current technology, presents its own set of challenges. The prolonged exposure to microgravity during spaceflight can lead to muscle and bone loss, cardiovascular deconditioning, and other health problems. Moreover, the psychological toll of confinement, isolation, and the inherent risks of space travel cannot be underestimated. Addressing these challenges will require innovative approaches to spacecraft design, crew selection, and in-flight healthcare to ensure the physical and mental well-being of astronauts during their long journey. Establishing a self-sustaining colony on Mars will require overcoming significant logistical hurdles. Transporting the vast quantities of materials and equipment needed for human habitation will be a monumental undertaking. In situ resource utilization, or ISRU, the process of using locally available resources to produce food, water, and building materials, will be crucial for minimizing dependence on Earth-based supplies. However, developing the technologies and infrastructure needed for ISRU on Mars will require significant investment and innovation. The social and psychological challenges of living on Mars should not be underestimated. The Martian colonists will be pioneers, venturing into the unknown and facing challenges never before encountered by humanity. The isolation and confinement of living in a closed environment, coupled with the stress of adapting to a new world, could have significant psychological impacts. Establishing a stable and cohesive society on Mars will require careful planning, effective communication, and a strong sense of community among the colonists. Transforming Mars from a cold, arid desert into a habitable world for humans will require a multi-pronged approach, combining cutting-edge technologies with a deep understanding of planetary science. Terraforming, the hypothetical process of altering a planet's environment to make it more Earth-like, has long captured the imagination of scientists and science fiction writers alike. While terraforming Mars on a global scale remains a distant goal, there are several promising avenues for creating localized habitable zones on the red planet. One proposed method for terraforming Mars involves releasing greenhouse gases into the atmosphere to trap heat and warm the planet. These gases, such as carbon dioxide and methane, could be released from Martian polar ice caps, subsurface reservoirs, or even manufactured on-site using Martian resources. As the planet warms, the frozen water ice beneath the surface could melt, creating bodies of liquid water and increasing atmospheric pressure, potentially making Mars more hospitable to life. Another approach to creating habitable environments on Mars involves building enclosed habitats. These structures, ranging from inflatable modules to underground caverns, would provide a controlled environment shielded from the harsh Martian conditions. Advanced life support systems would maintain breathable air, regulate temperature and humidity, and recycle water and waste, creating a self-sustaining ecosystem within the confines of the habitat. Vertical farming techniques could be employed to cultivate crops within these enclosed environments, providing a sustainable source of food for Martian colonists. Hydroponics and aeroponics, methods of growing plants without soil, would be particularly well suited for Mars, as they require less water and space than traditional agriculture. Additionally, genetically engineered crops could be developed to thrive in the Martian environment, potentially increasing yields and expanding the range of available foodstuffs. Three-dimensional printing technology could revolutionize habitat construction on Mars. Using Martian regolith, the loose rock and dust found on the planet's surface, as a building material, three-dimensional printers could create complex and durable structures with minimal human intervention. This technology could also be used to manufacture tools, spare parts, and even medical implants, reducing dependence on Earth-based supplies and enabling greater self-sufficiency for Martian colonists. Section 5. The Martian Pioneers, a new breed of explorers. The first humans to set foot on Mars will be more than just astronauts. They will be pioneers, embarking on a journey that will redefine humanity's place in the cosmos. These Martian explorers will possess a unique combination of skills, knowledge, and psychological resilience, forged in the crucible of rigorous training and driven by an unyielding spirit of exploration and discovery. Selecting the ideal candidates for a mission to Mars will be a complex and multifaceted process. Technical expertise in fields such as aerospace engineering, astrophysics, geology, and medicine will be essential. However, equally important will be psychological factors such as adaptability, teamwork, and the ability to cope with stress and isolation. These Martian pioneers will need to be not only highly skilled, but also emotionally intelligent and capable of maintaining a positive and productive mindset in the face of adversity. Training for a mission to Mars will be unlike anything experienced by previous generations of astronauts. In addition to mastering the technical aspects of spaceflight, such as spacecraft operations, extravehicular activity, and emergency procedures, Martian explorers will need to become proficient in a wide range of skills relevant to living and working on another planet. These skills may include geology, botany, construction, resource extraction, and even basic medical care. The psychological preparation of Martian explorers will be equally crucial. Simulated missions in environments that mimic the challenges of living on Mars, such as Antarctica or remote desert regions, will be essential for building resilience, teamwork, and problem-solving skills. Virtual reality simulations could also play a vital role in preparing astronauts for the psychological challenges of long-duration spaceflight and life on another planet. The Martian pioneers will be more than just explorers. They will be the vanguard of a new era for humanity, paving the way for future generations to follow in their footsteps. Their experiences, discoveries, and sacrifices will inspire generations to come, pushing the boundaries of human knowledge and expanding our understanding of the universe and our place within it. Section 6. A Society on Mars. Building a new world. The establishment of a permanent human presence on Mars will mark a pivotal moment in human history, the birth of a new society on a new world. This Martian colony will face unique challenges and opportunities, shaping its social structures, governance, and cultural identity in ways that we can only begin to imagine. As we contemplate the creation of a Martian society, we must consider not only the practicalities of survival, but also the ethical and philosophical implications of building a new world. One of the most pressing questions facing a Martian colony will be that of governance. Should the Martian colony be governed by Earth-based nations, or should it strive for self-determination from the outset? The distance between Earth and Mars, with communication delays of up to 40 minutes, makes real-time decision-making from Earth impractical. This suggests that a high degree of autonomy will be essential for the Martian colony to thrive. The social structure of a Martian colony will likely be shaped by the unique challenges and opportunities of living on another planet. Cooperation and interdependence will be paramount for survival, potentially leading to a more egalitarian and community-oriented society than what we see on Earth today. The limited resources and harsh environment of Mars may necessitate a strong emphasis on sustainability and resource management, potentially leading to the development of novel economic and social systems. The cultural identity of Martian colonists will be shaped by their experiences on a new world, their shared history as pioneers, and their evolving relationship with Earth. Will they develop a distinct Martian culture distinct from their terrestrial roots? Or will they strive to maintain a strong connection to Earth's cultural heritage? The answer will likely lie somewhere in between, as Martian colonists forge a new identity that honors their past while embracing the unique challenges and opportunities of their new home. The ethical considerations of establishing a human presence on Mars are profound. We must proceed with caution and respect for the potential of Martian life, ensuring that our actions do not contaminate or harm any existing ecosystems. Additionally, we must strive to create a just and equitable society on Mars, one that avoids the mistakes of our past and ensures that the benefits of Martian colonization are shared by all. Section 7. The Martian Economy, Resources and Opportunities. The colonization of Mars presents not only a scientific and technological challenge, but also an economic opportunity. The red planet possesses a wealth of resources that, if harnessed effectively, could fuel a thriving Martian economy, driving innovation and creating new industries both on Mars and back on Earth. One of the most valuable resources on Mars is water ice, found in abundance in the polar ice caps and potentially beneath the surface. This water ice could be extracted and purified for human consumption, used for irrigation in Martian agriculture, or broken down into its constituent elements, hydrogen and oxygen. Oxygen could be used for breathable air, while hydrogen could be used as rocket fuel or in fuel cells, providing a source of energy for Martian settlements. Mars is also rich in minerals and metals, including iron, aluminum, titanium, and rare earth elements. These resources could be extracted and processed on Mars, reducing the need to transport heavy materials from Earth. Martian-made products such as construction materials, tools, and even spacecraft components could be used to support the growing Martian colony, or even exported back to Earth, creating new trade routes and economic opportunities. The unique Martian environment itself could become an asset. The thin atmosphere and lack of a global magnetic field make Mars an ideal location for astronomical observatories, shielded from the atmospheric distortion and light pollution that plague Earth-based telescopes. Moreover, the lower gravity and lack of biological contamination make Mars a suitable location for conducting scientific experiments and developing new technologies that could benefit both Mars and Earth. Space tourism could become a significant driver of the Martian economy. As space travel becomes more affordable and accessible, Mars will undoubtedly become a popular destination for adventurous travelers seeking to experience the thrill of exploring another planet. This influx of tourists could create new industries on Mars, catering to the needs of visitors and generating revenue for the Martian economy. The development of a Martian economy will require innovation, collaboration, and a long-term vision. Governments, private companies, and research institutions will need to work together to overcome the technological and logistical challenges of operating in the Martian environment. However, the potential rewards are significant, promising to unlock vast new resources, stimulate technological advancement, and create a new frontier for human endeavor. Section 8. Ethical Considerations: The Responsibility of Interplanetary Travel. As we stand on the precipice of becoming an interplanetary species, it is imperative that we confront the ethical implications of expanding our footprint beyond Earth. The colonization of Mars presents a host of complex ethical dilemmas, from the potential impact on Martian life to the social justice implications of selecting who gets to go to Mars and what kind of society we build there. One of the most pressing ethical concerns is the potential for contaminating Mars with Earth-based life. While the existence of Martian life is still uncertain, the discovery of evidence of past liquid water suggests that Mars may have once been habitable and could potentially harbor microbial life today. Introducing Earth-based organisms could disrupt or destroy any existing Martian ecosystems, with unforeseen consequences. The selection of Martian colonists raises its own set of ethical questions. Who gets to decide who goes to Mars, and on what basis? Will it be limited to scientists, engineers, and other highly skilled individuals? Or will there be opportunities for people from all walks of life? How do we ensure that the selection process is fair and equitable, and that the Martian colony reflects the diversity of humanity? The governance of a Martian colony presents further ethical challenges. Should Mars be treated as a colony of Earth, subject to the laws and regulations of existing nations? Or should it be granted autonomy, free to govern itself and determine its own destiny? How do we ensure that the rights and freedoms of Martian colonists are protected and that they have a say in how their society is run? The potential for exploitation of Martian resources is another ethical concern. Will the resources of Mars be used sustainably for the benefit of all humanity, or will they be exploited for the profit of a few? How do we prevent the emergence of a new form of colonialism on Mars, where a privileged few benefit at the expense of the many? As we embark on this new chapter in human history, it is essential that we proceed with caution, humility, and a deep sense of responsibility. The decisions we make today will shape the future of humanity on Mars and beyond. We must strive to create a future where the exploration and colonization of space is conducted ethically and sustainably for the benefit of all humankind and for generations to come. Section 9. The Future of Humanity, Mars and Beyond. The successful colonization of Mars holds the potential to fundamentally alter the trajectory of human civilization, opening up a new chapter in our species' story and propelling us towards a future as a multi-planetary species. The challenges are immense, but so too are the rewards, promising to unlock new frontiers of knowledge, drive technological innovation, and inspire generations to come. As we establish a permanent human presence on Mars, we will develop new technologies and strategies for living and thriving in extreme environments. These advancements will not only benefit Martian colonists, but will also have applications back on Earth, helping us address challenges such as climate change, resource scarcity, and environmental degradation. The colonization of Mars could serve as a stepping stone to further exploration of our solar system and beyond. With a permanent base on Mars, we could launch missions to the outer solar system, explore the asteroid belt for resources, and even venture beyond the confines of our solar system to other star systems. The establishment of a Martian colony could also serve as a safeguard for humanity. By diversifying our presence beyond Earth, we reduce the risk of extinction from events such as asteroid impacts, pandemics, or ecological collapse. A self-sustaining Martian colony could ensure the survival of our species, even in the face of catastrophic events on Earth. The psychological and philosophical implications of becoming a multiplanetary species are profound. Expanding our reach beyond Earth will challenge our assumptions about ourselves, our place in the universe, and the very meaning of life. It will force us to confront our limitations, embrace new perspectives, and strive for greater understanding and cooperation as a species. The journey to Mars and beyond will be fraught with challenges, but it is a journey worth taking. It is a journey of exploration, discovery, and innovation, a testament to the indomitable spirit of humanity and our unyielding thirst for knowledge and adventure. It is a journey that holds the potential to transform our species and secure our future among the stars. Section 10. Conclusion. A giant leap for mankind. The prospect of humans living on Mars, once confined to the realm of science fiction, is rapidly transitioning into the realm of possibility. The challenges are significant, but they are not insurmountable. With ingenuity, determination, and a spirit of global cooperation, we can overcome these obstacles and establish a permanent human presence on the Red Planet. The journey to Mars is not merely about escaping the confines of our own planet. It is about expanding our horizons, pushing the boundaries of human ingenuity, and securing the future of our species. It is about fostering a spirit of exploration, discovery, and innovation that will inspire generations to come. As we stand on the cusp of this new era in human history, we must remember the words of President John F. Kennedy, who in 1962 challenged America to land a man on the moon before the end of the decade. "We choose to go to the moon," he declared, "not because it is easy, but because it is hard, because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one that we are willing to accept, one we are unwilling to postpone, and one which we intend to win." The same spirit of ambition, determination, and unwavering belief in the power of human ingenuity will guide us on our journey to Mars. It will be a journey of challenges, of setbacks, and of triumphs, but it will be a journey that will ultimately redefine our place in the cosmos and secure our legacy as a species capable of reaching for the stars and making them our home. The future of humanity lies not just on Earth, but among the stars, and the journey to Mars is the first step on that extraordinary adventure.